Hey everyone, today we're going to do two examples of using the binomial theorem to expand kind of tricky binomials. So for the first one, we have 5 plus root 3 all to the power 4, and we want to write it as a final answer where we have an exact value in terms of radicals, not as a decimal, because those are rationals, and so we would be rounding, right? And so we know that since this is a binomial raised to the power 4, we can look at the fourth row of Pascal's triangle, fourth row, and that'll give us the coefficients of our terms, of our 5 terms, and that fourth row has the numbers 1, 4, 6, 4, 1. So we can go ahead and start our expansion. So the first term is going to be 1 times 5 to the power of 4 times root 3 to the power of 0. I'll even write that out since it's our first example. Okay. And then the exponents on the first term are going to decrease. The exponents on the second term are going to increase from 4 to 0 and 0 to 4, okay? And the coefficients are going to follow that row of Pascal's triangle. And so we have 1 times so on and so forth, plus 4 times, now we'll have 5 to the power of 3, root 3 to the power of 1, right? And you guys see how the exponents go down on the 5 and go up on the root 3. And so we keep going, plus 6 times 5 squared times root 3 squared, plus 4 times 5 times root 3 cubed, plus root 3 to the power of 4. And now we hope to simplify everything down. So our first term is root 3 to the power of 0. Anything to the power of 0 is 1. And so all we have is 5 to the power of 4. That is 625 plus 4 times 5 cubed is 125 times 4 is 500, and root 3 to the 1 is just root 3, so that is 500 root 3, and we leave it as a radical, right? Next, we'll keep going. So we have 6 times 5 squared is 25. 25 times 6 is 150, and root 3 times root 3 squared is 3. And so we have 25 times 6, which is 150, times 3 is 450. And we get a nice constant term, much like our first one. For our fourth term, we'll have plus 4 times 5 is 20. Root 3 cubed means root 3 times root 3 times root 3. Root 3 squared is 3, so we get a factor of 3. And then we'll get one more factor of root 3 at the end. And so we'll get 4 times 5 times 3 root 3, right? I'll make a note of that. Root 3 cubed is really 3 root 3, right? And so that means that this becomes 20 times 3 root 3, which is 60 root 3. And finally, root 3 to the power 4 means 3 squared, which is plus 9. And now we can simplify this down into a constant term and into a root 3 term. So we'll have 625 plus 450 plus 9, which is 1,084, plus we have 500 root 3 plus 60 root 3s, and so altogether we have 560 root 3s, and here's our final answer. Okay, so that is part 1. For part 2, we have again a binomial, but in this case, because we're used to the general shape of a plus b to the power of n, in this case, our a is the first term of the binomial, and so a is 2x. B, let's be careful of our sign here, b is negative 3 over x squared. Every time we see a b, we need to put a negative 3 over x squared. And so this is to the power of 3, and so our third row of Pascal's triangle looks like 1, 3, 3, 1. So those are coefficients for our 4 terms. And so we'll start off with a 1 times 2x to the power of 3 times b to the power of 0. I'll omit it for the sake of time. Then we'll have plus 3 times 2x squared times negative 3 over x squared to the power of 1, right? Plus 3 again, so plus 3. Now we have 2x to the power of 1 and negative 3 over x squared to the power of 2. And last but not least, we have plus 1 times 2x to the power of 0. That's just 1, so I'll omit it. And negative 3 over x squared to the power of 3. And now let's expand everything and simplify. And so that will mean our first term, let's use the green marker. Our first term, 2x all cubed, is 8x cubed. Our second term is, actually that'll be a minus because of the negative. 2x all squared is 4x squared. 4x squared times 3 is 12x squared. So we'll have 12x squared, maybe I'll write it down, plus 12x squared times negative 3 over x squared. We can do that out in the next line. Then we'll have plus, that means 6x times negative 3 over x squared becomes 9 over x to the 4. And finally, negative 3 cubed is negative 27. So that will be negative 27 over x to the 6. And now let's finish this off with one more line of simplifications. And so our final product will be 8x cubed, minus, here the x squares conveniently cancel out. And so all we have is minus 36. Happens sometimes. Next, we'll have 6 times 9 is 54. X over x to the 4 simplifies as over x cubed. And our last term is already in its simplified form. And so here is our final answer. Again, just an expansion using the binomial theorem of a plus b to the n, where the first term in the binomial is a, the second term in the binomial is b. Two different examples, one using radicals, one using a variable. Hope that helps. If you guys have any comments, suggestions for videos that you'd like to be done out, please do let me know, and thanks for watching.